And we will get started. So last time we talked about the idea that there's a $1 bill, a $5 bill, a $10 bill, a $20 bill, and a $100 bill. And there's actually occasionally a $2 bill that you might see in circulation. Okay.
Okay.
Oh, before I even get any further, do you have a notebook out to take some notes for today?
I'll go get it.
Okay.
Okay, I got it.
You got it. Fantastic. All right. So the first grouping of numbers here are is the paper money that we use in this country.
Okay.
Now, have you traveled to another country in your lifetime?
Yeah.
Which countries have you been to, or which country?
I went to India, New York, California.
Country. So India is another country. Do you remember the paper money that you might have seen there?
The paper money.
Yes. Do you remember what kind of paper money that was there?
Mm,
The currency?
kinda. I don't know.
So I believe it's the rupee. Do you remember
Ru-
that? Rupee. Yeah.
The rupee.
Yeah. I believe that's what it is in India.
Okay.
But in this country, we use dollars, and we have a $1 bill, a $5 bill, a $10 bill, $20 bill, and a $100 bill. Now, how about coins? What is the smallest coin, and not in size, but in value, that we have in this country?
Okay.
What is the 1 cent coin called in our country?
The 1 cent a coin.
Yes, what is that called? Do you recall?
1 cent. It's 1 cent. 1 cent equals 1 cent.
We have a special name for it, though.
The penny.
The penny, that's right. And what is the 5 cent coin called? Do you recall?
Nickel.
Nickel, very good. 10 cent coin is
Dime.
dime, very good. And then how about a 25 cent coin?
Quarter.
Quarter, very good. All right, give me just a moment here. Do you remember, have you ever seen a 50 cent coin?
Yeah. That's uh a 50 cent coin. That's a big coin.
It is, it's called a $50.
A $50.
And there's actually $1 coins, if you can believe it or not. But these are less rare. Okay, so the most common types of coins, though, that we have are a penny, a nickel, a dime, and a quarter. Penny is 1 cent, nickel is 5 cents, dime is 10 cents, and a quarter is 25. So you can think of it as 1, 5, 10, and 25, like that. Okay, so let's say, Sourish, you want to give a friend, let's say you want to give a friend 19 cents. Okay. What is the fewest number of coins that you could give them?
The fewest number of coins if you get it, you said.
Yeah.
Uh,
So it's kind of like the question that we were looking at the other night with dollar bills, but now we're doing it with coins.
okay. All right. I would say that that's fewest. It's a penny.
So
One.
a penny is just 1 cent though. We need to get all the way up to 19 cents. So we got 18 more cents to go.
Okay.
So remember from last time, we actually start with the largest one that goes into it.
Yeah.
What is the largest coin that goes into 19 cents?
Nickel.
Nope.
A dime.
Dime, yeah. So you would start with a dime. So if your goal is 19 cents, you would start with a dime. So 1 dime is how many cents?
10 cents.
10 cents. So we're not quite there. How many more cents do we need after the 10?
How many more cents we need out of 10?
Yeah. What's left over? The 9 cents.
Yeah.
So what's the smallest?
We
I'm
just
sorry.
subtract.
What's the largest coin that goes into 9 cents out of these?
A nickel.
A nickel. Very good. So 1 nickel is 5 cents. And that means we have left over now 9 minus 5, 4 cents. What's the smallest coin that can go into that?
Okay. And now we need to find out the smallest.
Well, what goes into 4 cents? How can you make 4 cents?
That's a penny.
Well, but it's more than 1 penny. How many pennies is it?
4 pennies.
It's 4 pennies. Okay. So that gets you to 4 cents. And then that's your leftover 0. So how many coins did you need to do that?
So you have to add those things right there. That equals 6.
6 coins. Very good. Okay. Let's have you try one on your own. All right. Do you have any questions though before we get started on that one?
I'm good.
Okay. All right. Let's say you want the fewest number of coins to make 38 cents.
Yeah. Okay.
All right. So take a little bit of time here and let
Fewest
me know if you
numbers
have.
of coins to make 38 cents. Okay.
Yes.
First of all, you need a quarter.
I want you to work this out until you've got your final answer. So you're going to work it out on your paper.
Can you go back to the previous problem so I can review?
Sure, but did you write it down?
Yeah. I just want to know. Okay. Come on, back down.
Okay.
Eight.
Okay, so you said 8 coins, all right? What are the 8 coins?
What are the 8 coins?
Yes.
The 8 coins for that. So you need yourselves 8 pennies.
Okay, 8 pennies.
You have 1 nickel,
Okay, 1 nickel.
and that's it.
So 8 pennies is 8 cents. Do you agree with that?
Yeah.
1 nickel is 5 cents. How many cents does that add up to?
Eight plus five, that's 13.
What did we want?
What do we want? We need to be able to just make yourselves to get to 38.
That's right. So 13 is not 38. So this is not correct. So we're gonna have to start over.
Okay.
So just like in the previous problem, you want to figure out the biggest coin that goes into 38 cents. The biggest coin that goes into 38 cents.
Okay.
So let me grab this here and snip down here. So again, your options are a penny is 1 cent. A dime is 10 cents. A nickel is 5 cents. Put that in the wrong place. Let me switch the order on that. And then a quarter is 25 cents.
Okay. Okay.
So you want to figure out the biggest coin that goes into 38 cents.
Okay. Yeah. And so you need for so okay. So now so what you need is so in order to get 38, first of all, put 1/4.
I want you to work this out on your own. I want you to give me a final answer just like you did the last time. You said, okay, Matthew, the answer is 8 coins. And then we worked it out. So take a few minutes and give me the final answer.
Okay.
Do you have an answer for me, Sourish?
Yep, I got it now.
Okay, what is your answer?
My answer, my answer that I got is 24.
24 coins.
Yep.
Okay, that's a lot of coins. I mean, it's possible. We want the fewest, Sourish. What is the largest?
Oh. I thought you're just saying that then there needs to be a bigger number that needs to go in there.
Well, there is. A quarter goes into 38 cents. You should start with a quarter.
Start with a quarter, okay, 25, and then
How
and
much
we
is left over?
1 quarter. 25 is just 1 quarter.
So 1 quarter is 25 cents,
Uh-huh.
and that means you have 13 cents left over.
Yep.
So what's the largest coin that goes into 13 cents?
The largest coin that goes to 13 cents. Dime.
Okay, so 1 dime is 10 cents. And how much is left over? 3
3
cents.
cents.
Okay. So what's the largest coin that goes into 3 cents?
Wait, how did you get 13 for 1 quarter?
That's what's left over. 38 minus 25 is 13.
Oh, okay. So yeah, and now for that right there, now for that, now we need 3 pennies.
Yes, 3 pennies, 3 cents, and 0 is left over.
Yep. So you have to add those, and then that's gonna give you 5.
It gives you 5 coins. Very good. Okay, so we did our math problem, and we're gonna do a little bit of geometry because I don't feel like you fully understand the side, 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 angle, side, side, angle, and angle, angle, side. So you will need to take notes. I will ask your dad if you've taken notes. And I'm also going to have you do some problems. So please take some notes for this part of the lesson.
Okay.
Okay. So we're going to start with side, 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 side. And I'm going to draw 2 triangles. But I'm going to label them A, B, C, and X, Y, Z.
Okay.
And I'm going to tell you that AB is congruent to XY. So these lines here, this line right in the middle means that they're congruent.
Okay.
Now, BC is congruent to YZ. That means when you have 2 lines, they're also congruent. That means that the line segment BC is congruent to YZ. So do you see now that we have 2 sides that are congruent in this triangle?
Yeah.
So now I'm going to label the third side congruent, AC congruent to XZ. And now it fully satisfies side, 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 because all of the sides are congruent.
Okay. All right. So this is a side angle. So this is side, side, side because it needs to be
Side,
like
side, side. Yes, yes.
because
Okay.
how do you explain that? It's because there's some
All 3 sides are congruent. All 3 sides are congruent.
okay.
Right.
Okay.
So did you write this down? Did you get this down in your notes?
Um I'll just get that down my notes. Okay. Okay.
You've got that down?
Uh-huh.
All right, great. So let's look at two new triangles here. All right, I'm going to draw the triangles here. Let's go A, B, C. Let's go D, E, F. And let's say that AC is congruent to DE, BC is congruent to DF, and AB is congruent to EF. Are these triangles congruent?
Are these triangles congruent?
Yes.
The first one is, but not the second one.
No, they have to be congruent to each other.
They are congruent.
Yes, they are. Now, what is it about them that is the same in both triangles? How are they congruent? And there's four options, right? There's side, 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 angle, side, angle, and angle, angle, side. Which of these four is the reason that these are congruent?
Side angle side.
Side, angle, side. Okay, so what angle is shown as being congruent to another angle?
The DEF.
Sourish, do you see that all three sides are congruent?
Yeah.
So which of these four is for all three sides being congruent?
Angle side.
I don't feel like you're answering my questions here. So we're going to take a short break. We're gonna pause here for 2 or 3 minutes. 7:27, I will jump back in. Okay.
Well, okay, yeah.
Hey, Sourish, are you back?
Yeah.
Awesome. All right, you ready to get started here?
Uh-huh.
Okay, so I've in the couple minutes break here, I was trying to think about how to better explain this, and I'm gonna try here with something a little bit different than what we've been doing. But hopefully it will work out here. So let me grab an image here. Just need to grab an image real quick. Okay, so I'm actually going to draw something here. All right, so here I've drawn, how would you describe what I've just drawn?
This right there, that, wait, what?
Just give me a description of this, because I don't want to bias you. What would you call this right here?
A coordinate plane.
Okay, I agree with that. Is this the same as the image on the left?
Yes,
Why is it the same? Because they are,
because they
they're
both have
absolutely.
same size right there.
Okay, I agree. All right. Now, what if I rotate it slightly? Is it now the same?
No,
Why isn't it the same?
because it's an X. It's not even the same like that.
But if you rotate it, it is the same.
Well, yeah,
Okay, and so okay, this is important for me because I'm trying to figure out what's the there's some sort of disconnect here. So let me draw a shape now. How would you describe this shape? Is there a word you could use to describe this shape?
that's a rectangle.
It's a rectangle. Is it the same as this rectangle here?
As this rectangle here. Well, no,
Why is it different?
because it was rotated upside down.
Okay. So think of this on the right here as your phone.
Okay.
And you're just holding your phone. If you rotate your phone, is it different? Is it now a different phone?
Is it now a different phone?
Like you imagine you're
Yes,
holding
yes.
it is, so you have two different
But
phones?
that right there, the first one, that's an iPad.
Well, no, it's the same phone. I mean, it's you have a phone and then you rotate it and it's the same phone.
Yeah. Mhm.
Well, do you agree or disagree? Because I mean, you hold your phone
I
one
agree.
direction.
I agree.
Okay, okay, because that's important here. It's like there's something else that's happening that I'm not quite sure about, which is why I keep asking here. So rotations don't matter. Rotations don't change the object.
Okay.
All right.
Rotations don't change the object.
So let's look at something else. So there's another object. Is this the same object?
Is this the same? Is that the same object?
Yes.
No,
Okay. So why is it different?
because it's from a different side. You know what I'm saying. It's different because the sides are in a different way.
So it's actually the same. It's just rotated. And that's what I'm kind of learning here about you. There's something that's challenging you to be able to see the rotations of these objects. And that's okay. I'm just trying to figure out how to best help you here. So let me see if I can grab a snip of this and let me see if I can rotate it. Doesn't look like I can rotate it in this format. Let me do it here. All right, so all right, so do you see now that I can take the image and rotate it and it becomes you can actually move it. Have you ever played Tetris before?
Tetris? No.
This would be a really good game for you to play. I'll recommend that to your dad. You have to rotate shapes to do this. Okay. So let me, not sure what else to do here. Okay. So there's a disconnect here. That's okay. I'm going to grab some SAT questions for us to talk about. So give me just a moment here. All right, we're not going to do quadratics quite yet. These are not going to work. All right, here we go. I found some questions that we can look at here, and then we'll just spend a little time doing this.
I don't see it.
Yeah, I'm about to snip it in. So you won't need to take any notes for that.
Okay.
All right, so I'll read this problem out loud. It says, which of the following is closest to the percent of those surveyed who had a summer job? A survey of 170 randomly selected teenagers aged 14 through 17 in the United States was conducted to gather data on summer employment of teenagers. The data are shown in the table below. So this table shows on the left here the age of the person, so 14 to 15, 16 to 17. And it's saying, for example, that 20 people who are 14 to 15 have a summer job. And 39 people 16 to 17 have a summer job. But similarly, or not similarly, in this next column here, they're saying that there's also people that do not have a summer job. So are you 14 to 15, Sourish, or are you 16 to 17?
I'm 16.
So you would be in one of these groups. You either had a summer job or you did not have a summer job next summer. Okay. Now let's go back to what it's asking for. It says, which of the following is closest to the percent of those surveyed who had a summer job? So how many people had a summer job?
How many people have a summer job?
Yes.
How many people had a summer job? The total is 170.
Yes, that's all the teenagers, but not all of them had a summer job.
It's 59.
That's right. 59 had a summer job. And now you need the total, which you just told me.
Yep, 170. And you subtract and you divide.
Yes. Now you would have a calculator for this. Do you have one, or can you use one on your computer?
I'm doing it on the computer. $35.
Yes. Very good. Okay, let's look at another question here. You've done really well with these table problems, so let's take a look at another one here. There's a lot of words, and I know that that's challenging for you, but that's okay. We can do this. So this table says the number of adults contracting colds. Okay, number of adults contracting colds. All right, so the number of people who got the cold is in the first column here. No cold is in the second column. And the rows, they suggest that they took vitamin C or a sugar pill. Maybe you can ask your dad about that at some point, whether that's good or bad. I have no idea.
What?
So some people believe that taking vitamin C helps to reduce having a cold,
Cold.
like
Wait.
being sick.
Yeah, how many people can get okay. So yeah, it's about people getting sick.
Yes, but not everyone got sick. Some people got a cold, some people did not get a cold.
Okay.
All right, so we've got the table shows the results of a research study that investigated the therapeutic value of vitamin C in preventing colds. A sample of 300 adults, so that's the total number of people, received either a vitamin C pill or a sugar pill during a 2-week period. And they were asked to report whether they contracted a cold during that time or not. So the question is, what proportion of adults who received a sugar pill reported contracting a cold? So what we care about the people with a sugar pill, or I'm sorry, yes, with a sugar pill. So we care about this row right here.
Okay. 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 All right. So, all right. So I'm gonna be doing what proportion are received. Okay. So the total is, so you have to subtract, right?
You want to know how many people that took the sugar pill. So how many people took the sugar pill? Let's just start with that.
How many people took the sugar bill? 150.
150. And you care about those that contracted a cold. So how many people contracted a cold in this row right here?
I tracked the cold as 33.
Yes. Now, do you see that answer here?
And do you guys see that answer? No. There's no answer, but you should divide. Hello?
Yes. So what can you divide each of them?
33 divided by 150.
Yes. What goes into both of these numbers?
Let me think.
So do you see that the number 3 goes into both of these?
Number 3 goes into both of these. Yeah, I'm trying to get into this. I'm trying to get into the mechanic right here. Wait, 11. Yeah, I know the answer. Okay. So I think I know the answer. 1150. Is it? Hello?
Hey, Sourish, good job. Sorry about that. I was muted. Is your dad around for some feedback for tonight? I want to give him some ideas about how to help you with
Did I
some
do it
money.
wrong?
You didn't do anything wrong.
Okay. Well,
Everything's
thank you,
fine.
Matthew.
Yeah, you're welcome.
All right, Dad. Hello, hi.
Hi, Dr. Kithari. So just stopping a little early because I want to get some more dialogue with you about some ideas to help Sarish with money. So you and I mean, I don't know about you, I don't use cash all that often.
Yeah.
And coins even less so, but they're still prevalent in our society. And I mean, we still kind of need to know what's going on.
Right.
So I posed some questions to Sarish, like, let's say you wanted to make 19 cents and you had as many quarters, nickels, dimes, pennies as you needed. And, what is the fewest number of coins that you might need? And so one of the things that I think is he's really struggling with, and it doesn't work well in this virtual environment, is if he had coins to touch and to move around. This is 1 dime, and it's 1 nickel, and then it's 4 pennies. And I think having the coins there would really help him to be able to answer some of these questions.
Okay.
And I guess what I was going to suggest is that if you guys have some spare coins laying around to play some games like, let's say you want 72 cents, and what is the fewest number of coins? What is the most number of coins? And I think touching the coins would really help him to see it, to visualize it.
Okay.
Yeah,
I think I have coins,
Good. Rather than doing it with like paper money, obviously, because that could get kind of expensive, but coins we have lots of access to in general. Because it's the same problem with the paper money. It's like how do you make $42 and do it in the least, or in the most economical way, where you're not just handing people $1 bills for $40. And I know you probably had I'm guessing you wanted something slightly different but this is just a basic understanding of money, and then we can get to like making change and discounts and stuff like that. But I guess my perception is that there's some sort of a disconnect between like what goes into the coins and the dollar amounts to be able to make change. So that's the first thing I wanted to just throw at you.
Okay.
We talked about, I'll get to some discounts and tips and all that too, but it kind of starts with that. The second thing, this is kind of really an interesting thing to me. So Sourish, we're looking at some problems, and at first he said that this shape is different than this shape. And we talked about the idea of holding a phone and then rotating the phone. But because they're really the same.
Right.
And I think he got that idea. But when I said, how about something like this, which is it's kind of the same thing, but I said, well, what if we look at one over here on the right? He thought that these were different initially, and that there's something inside his brain that just doesn't see that it's a rotation. And it got me thinking about the game Tetris. And I don't know how you feel about that, but it's just, if you could find just a basic Tetris game, it really shows you how to manipulate these shapes to fit them into different spaces. So I would recommend something like this to show him how these things fit together, because he should be able to rotate these without actually having to draw them.
Okay. So I think that Tetris is like it's like a puzzle game, right? Where
Exactly.
you make some shapes. It has different shapes and all. Okay.
And I would look for a very basic version of Tetris, because there's so many variations on it now, like Candy Crush and all this other garbage that he doesn't need. He needs like the bare bones Tetris.
Right. Okay. So I'll try to find something. I may have it. I have to look. And then you can. Sometimes his brain is different.
Exactly.
So,
and there's nothing wrong with it. It's something about it it's like, and we want to be able to help him, and he likes games. So as much as I don't want him to be in front of a screen, I do think this could actually help him if he, could rotate the shapes and see that, and he will, because all of this was for triangle congruence. So like if I flip a triangle, he may or may not see that it's congruent, and it all comes down to the shapes that he's looking at.
Okay. So I'll find this Tetris and what? That game, I know that game, but I haven't played it. Okay, we have it right at home. I think I'll look for it.
Tetris, no.
You know what Tetris is?
Yeah,
Okay.
it's like some kind of video game people that's very famous.
Okay.
All right.
Yeah, I know. So
Does he play chess or have any interest in chess?
I used to play chess, but I was playing chess. I'm not good at chess.
Okay. I mean,
I'm not good at chess.
Well, it's an extension of like this with the movements of the patterns of the
Right,
moves, and it
Yeah.
could be helpful, but if it's beyond, you got to be able to do something else before you get to that.
Yeah,
So
right. Yeah. I mean, I think you are doing right things with him. So, and eventually once he knows that coins and dollars, then, my thing is, when you go to shop, you take $10, you buy, like 2 pens, which is $2 each.
yes,
How much money you'll get back?
right,
So it is $4 is 2 pence, and then you have $10, you will get back $6 money back, right?
right.
This is there are like 3 steps here.
Right.
So he has to process that.
I mean, you'd be surprised how often people give you the wrong change, and I mean, not that they're trying to steal from you or anything, but you're just shocked that people don't know how to return the money the way you would expect. And it's obviously it's easier when you're sliding a card, but I mean, there's still some value in this.
I mean, sometimes, now with all the credit cards, no one is using
Right.
money, real money.
Right.
So I'm not sure how much it is useful for him,
Mhm.
But again, it's important to know at least some things. Even if you take the credit card, when you're buying things, you should know how much it's going to cost, how much the credit card is charging, things like that, So, I mean, these are basic things, but, for him, it is like a struggle, challenge.
Yes.
So,
yeah. So we'll just keep at it. I'll try some different money problems next week, and
so take your time. I mean, first to finish his work, and then last 10 minutes like that, a little bit, fun
Yes.
kind of thing. So over a period of time, you might get at least something into his brain,
Right.
That's better than leaving as it is, So I mean, when he goes into the real world, eventually will learn with some difficulty, with some losses and all, eventually. But we want to try now itself, a little bit slowly,
Yes.
Okay.
All right. Well,
Anyway, thanks for helping
yeah,
him.
of course,
I
of
really
course.
appreciate. So.
Yeah. No, I appreciate you guys. You guys are great customers, and I love having you guys on the schedule each week, and we got 2 more full weeks, and we'll just keep going.
Yeah. Okay. Yeah. Thank you.
Okay.
Bye.
Bye. You're welcome.